So welcome to the another week, and let's start to solve the questions for the assignment of week 2. Okay. The question number 1 is, we have a real signal xt. This is a real signal, and it has a Fourier transform x of f. So basically xt, if we convert it in the frequency domain, it will become x of f. So the question is, what is the magnitude of the Fourier transform of xt? I mean, what is the magnitude? Let me write it. What is the magnitude So basically, what is this x? So basically, we started with a signal xt, that is a real signal that has a small x representation, and if we convert it into the Fourier domain, it will become x of f. It will get some another representation. So for example, xt, if the xt is a squared signal in this domain, if we do the Fourier transform, we know it goes like sync pulses. So this xt means, for this sort of example, this is a square wave and this x is a sync function in this case. So the question is, if we take a time domain signal that is sync sort of thing, then what will be the magnitude of this Fourier transform? That means, what will be the magnitude in terms of small of x of f? So basically, it was the question, and this question arises from the duality property of the Fourier transformation. So the question is, let me write the question once more because I explained some example first. So we have a signal xt that is a real signal, and we did a Fourier transform over it, and it becomes x of f. So basically, in following the duality property, x of t, if we take in the domain, what will be the magnitude of the Fourier transform of this? So first option is x of minus f. Second option is x of f. Third option is both a and b. And the last option is none of the above. So, what will be the correct option?
Sir, what is the nature of time domain signal? It is real, sorry, even or odd?
It is only real. We have not mentioned whether it is even or odd. Only thing that is mentioned that it is real. So basically, it is known that if some signal is real in one domain, then in the another domain, it will have a event spectrum. This follows from the duality property. So option A will be correct and option B will be correct because these two will have equal value. X of minus f and x of f, both of them will have equal values. Because why? The spectrum is event spectrum. So whether we go in the negative f axis or positive f axis, the value will be same because spectrum in the frequency domain will be even. Because we have taken the in the time domain, we have taken the signal as real signal. So following this duality property, the actual answer will be option C, both A and B. Is it okay with everyone?
Sir, real means even conjugate, na sir?
Real means even conjugate in the sense what you want to mean. That is the question.
Like Fourier series is for real signal, the coefficient are real conjugate symmetric, na sir? From that we are discussing, we are saying that it is option C, sir.
Pardon? Can you repeat once again?
In Fourier series, for real signal, the Fourier coefficients are conjugate symmetric, na sir? So that here it is even spectrum, sir.
Yes, I mean in the sense you can say x of t is equal to x star of t. That sort of thing you can say. So basically, if xt has two components in the sense xrt
plus jxit, then x of
plus jxi, then x of t will be equal to x of x star t only if this terms has a value x of it term has a value equal to 0. Only at that case this thing will happen. So that is the only thing we mean, what we mean by real signal. So if xt is a signal and it has the real part and the imaginary part, only the real part exists for this signal, not the imaginary part. So that is the why we say that is conjugate sort of thing.
Okay.
Okay, let me give a little more minute. There are some technical problems are here.
So can you write in the chat box whether I am audible right now? At least once. And whether there are multiple. Okay. Fine. Let us move to the next question. The second question is sort of the DC value. DC value, by what do we mean by DC value? DC value is like in the Fourier series we have seen that there is a coefficient A0. It did not have any harmonic associated with it. So they said the value as the DC value because it is the average value or the mean value. So or you can say what is the value at omega equal to 0 in the Fourier domain representation. So the DC value of a real signal is defined as x of 0. So x is the, if I have a signal xt and correspondingly we have a Fourier transform x of omega, so DC value will mean omega equal to 0. So this is the value x of 0. So it is well clear for everyone. So let me write the question once again. The DC value of a real signal xt is defined as x of 0, where x of f is the Fourier transform between these two. So if question is, if x of 0 is bounded, then the DC value, I mean the average value of the signal that we'll get if we do the 2 times the derivative of the signal xt with respect to t, that is d square by dt square xt, what will be its value? The first option is 2 pi and x0. This big X denotes the Fourier transform and the variable here is in omega, like this. This x is this x. The option B is 0. So basically it does not depend on the frequency spectrum. Option C is 4 pi x0 and option D is pi x0. So what could be the answer in this case? Anyone? Just type in the chat box, that will be fine. Okay, let me solve it. So we have a signal, real signal x of t, and we are just doing double derivative of that signal, right? So if we do double derivative, what does that mean in terms of Fourier transform? What happens to this function or with respect to the angular frequency x of omega? So x of t is equal to minus infinite to infinite x of omega e to the power j omega t dt, sorry, d omega. So basically, if with the first derivation here, there is a term e to the power j omega t, right? So according to Fourier transform, whenever we do the integration with respect to t, this variable, one omega term will come out of this and j omega. Similarly, if we do the double derivation, it will be j omega square. So that is j 2 pi f square. This term will come out of j 2 pi f square. This term will come, and it will be the rest of the thing will remain same as the derivative is here. So this terms comes out, and the rest of the things are like I represent this whole term as the x of f, as it remains the same. So just it is getting multiplied by j 2 pi f square or j omega square. As many times as I do the derivation, it is getting multiplied by j omega term multiplied by that. So basically the question is asked that what is the value at omega equal to 0? So whatever the value of this, it does not matter. It is just getting multiplied a factor, that means 2 pi f equal to 0. So it is just getting multiplied by a factor of 0, right? So it will be 0. Anything multiplied by 0 is 0. So the right option is option B. Okay. Now let go to the third question. So the third question says, so yes, what is the question?
Sir, putting omega equal to 0 means time is free, infinite. So area must be infinite now, sir.
Which one? Here
Second,
to 0.
omega equal to 0 means time equal to infinity. So putting when derivative is applied on the frequency domain, time value will be.
Okay, it does not mean that omega equal to 0 means time equal to infinite, right? Omega is the frequency. So you can interpret that it is periodic with infinite frequency. But it necessarily does not mean that the time you are counting at infinite. It says that after infinite time it will be periodic. But I am considering what is the component of omega at that. That means it is not sort of periodic. We can think that it gets I mean, whether you write it, it actually depends on f is equal to 1 by t. So basically, if this goes to infinite, it becomes 0. It tends to infinite. It's not exactly infinite. That is the first condition. Even if we think like that, we say that f equal to 0. That is the condition. I say it is not periodic. You can think like that. Or you can think that the time tends to infinite. Time goes to, after infinite amount of time, it becomes 0.
Okay, sir.
So basically this is a notation. It is actually DC value. If you have a constant 5 volt, that is not periodic with any time. A constant 5 volt, I am not saying a square wave, a constant 5 volt that has been generated from the beginning of the universe and still continue to go. So we can think after the universe ends, it may end. So basically that time goes to infinite. That is the concept here. So basically it represents what is the actual DC value, not the AC value type of thing. So that is why I am mentioning it is the DC value sort of thing, or what is the average sort of thing. That is a bias type of thing you can think of like that.
Okay, sir.
Okay, that's a good question. So third question. Third question is, I have a signal yt, and this yt is x of t minus t0 into cos of 2 pi f0t, where f0 is greater than fm. I will say what is fm later, and x of t is a band limited signal. Which has a bandwidth this is bandwidth fm. So f0 is greater than this fm. What is the bandwidth of this? So if the energy of xt is E, find energy of yt. The first option is E, second option is E by 2, third option is E by 4, and last option is none of them. Option A is for this question. It is not option A. It will be, because you see there is a term multiplied by cos. Okay, let us discuss. So let's write this function once again. Some yt was x of t minus t0 into cos of 2 pi f0 t. So the first property is here. It is a time shift property. So basically you have a pulse, and you have a pulse, the same pulse goes after some time. Both of them will have same energy. So even if we shift the signal by some time, only shifting the signal, nothing else, by shifting by t0, it does not change the power. So shifting by this t0 does not mean anything. So it is the same energy, it will be the same as cos 2 pi f0 t. They will have the same energy. Now the key point here is, xt is a signal and it has a Fourier representation x of f. So basically this signal, this is getting multiplied by a cos function. So basically it will happen a convolution in the frequency domain with the delta function, because we know the cos function has a del of f plus f0 and f minus f0 component. Del of f minus f0. I mean, if we have a cos function and if you plot the frequency domain spectrum, it will be like this at f0 and minus f0. So basically, if we multiply in the time domain, it will get a convolution with this signal. So basically, if there happens a convolution with the actual del pulse here, these are the del pulses. So for these, the equivalent Fourier series will be half of x of f plus f0 and x of f minus f0. There will be two components. So basically, for here, as the x has energy E, it will get 4 as this is the only signal in the frequency domain. So if we want to calculate the energy following the Parseval's rule, f plus f0 mod square by 1 by 4, because this term will also get a square if we calculate the energy. So for this term, we will get a E by 4. Similarly, for this term, we will get a E by 4. And the total energy will be E by 2.
Sir, why it is E by 4, sir, instead of when it should be x of when a signal is shifted, its magnitude, its energy will be same, sir. So x of f plus f naught and x of x plus x minus f naught.
But there is a multiplication factor of 1 by half, right?
Yes, sir, but still 2 times energy divided by 2 will be E na, sir.
2 times energy divided by 2. I mean, you can just write it as two different signals, right? I mean, so basically I can write that, right? Right?
Yes, sir. Each is
Has no interpart. That means f0 is, I mean, it is less than that. Sorry, the reverse condition. f0 is greater than. I mean, these two term has no spacing between them. So basically, it has 1 by 2 term, and this is also 1 by 2 term. So basically, if I take the energy here and here, they have no cross terms. So basically, I can write like this, right? Is it?
yes, sir. Yes, sir. No, orthogonal. Yes, sir.
Yes. So basically, if I take the magnitude square here, so 1 by 4, it comes out. These two, 1 by 4 comes out. And this frequency shifting property does not change the energy, right? So basically, it will remain as the energy of the x also. Sorry, it will be E. I mean, it not, we are writing it E. The question is, we have mentioned somewhere in the question, like xt has energy E. So E will be here because this frequency shifting property does not change the energy of the signal. But
Yes, sir. Got.
only thing is it is getting multiplied by half. As I am multiplying, just multiplying by cos function, right?
Yes, sir. Got it, sir.
Yeah. So basically, you can think also like we have a cos function. So basically, what is the energy of that cos function happens there? Like you can calculate the power of the cos function, and you will see that there is a half term comes for every a square by 2 terms. Like you have a cos omega t, and the power will be a square by 2 in that case. So basically, this 2 term a square by 2 terms comes. So similarly, here there was nothing term, so it will give a 1 by 2 term here also, sort of thing.
But 1 by 2 is not squared, na, sir. But we are squaring 1 by 2 also.
Yes, but it is in the time domain. I'm just trying to say you a consequence of this.
Okay, sir. Okay.
So basically, if you transfer in the frequency domain, you will find that there are two different things are here. So basically, half, and if you take 1 by 4 plus 1 by 4, that will be half, right?
So it divides the magnitude also, sir.
Yes,
Okay.
yes. What is the Fourier transform of the cos function? That is half delta, right?
Yes, sir. Yes, sir.
So that
Delta.
half will remain here. It is not exactly delta. So you have to take what is the power here and what is the power here, and then sum up them according to Parseval's theorem, right?
Okay, sir.
Okay, fine. The next question is, it is somehow related with a periodic function. So say xt is a periodic function with a time period of t is equal to 2 pi. So we define the period also like it is from pi to pi, not 0 to 2 pi. So within this time period, xt is equal to t. So basically xt also will have a Fourier series representation c of n is equal to, within this period it is except t is equal to t. So if we know what is the Fourier series representation, once again this question is related to the Fourier series type of thing, and exponential jnt. So this is another representation of the Fourier series, we know. Then it is easy to show that there is no DC term in this equation, Cn equal to 0. Then the question is, find Cn for n not equal to 0 and n equal to even. What is the representation of those Cn values? So just I think I'm still visible. So the question is, once again, I have a signal xt and it is I have a signal xt and it is periodic with time period t is equal to 2 pi, and the period is also minus pi to pi, and it has a value x of t equal to t. So basically there is no DC value sort of thing. So it says Cn equal to 0 for n equal to 0. The question is, what will be the value of Cn when n is not equal to 0 and n is even?
Not audible.
I think I'm audible now.
Yes, sir.
So I was explaining the question 1 second. So it says that xt is a signal with t is equal to 2 pi. That is a time period, and it is from minus pi to pi. So we have to find the Fourier series representation of Cn for n not equal to 0 and for n equal to even. So I will solve this question. So you guys can also think a little bit about it first. So this is pretty straightforward question. So we have to find what is the Cn values. Cn values are 1 by 2 pi minus pi to pi t exponential of minus j n t dt. So it will be equal to 1 by 2 pi just do the integration by parts. And the limit, substitute the limits. So basically, if we solve this integration, it will come minus 1 to the power n j, that j is a multiplication, not to the power j, by n and j by n for n equal to even. So this question was like a pretty mathematical straightforward question with just you need to do the derivations. So I don't think I have to prove anything or explain anything here for this question. The next question a bit interesting here. The next question says you have a function xt, and this xt is a triangular shape function pulse, and can be written as 1 minus mod of t by 2t within mod of t is less than equal to 2t, or 0 elsewhere. So basically this will always give a triangular shape function within the particular time period 2t, and it has two different slopes, and both the slopes will be like this. So this function will give triangular shape of function. So basically the question is, what is the, why we have taken the mod, it is clear to each of us, I think. Because if we do not take the mod, it will not get this triangular pulse. You can just substitute a particular t values for negative t values and positive t values and just draw the signal for yourself, and you will find that this equation represents a triangular pulse, and this will be a periodic. Why? Because for 2t minus t to t minus t to t, probably this is periodic. After that, again another triangular pulse that is defined by this equation. So this xt will have a Fourier transform that will be x of f. So question is, what will be the Fourier transform? First option is t sin square pi ft. Option B is t square sin square pi ft. Option C is 2t 2t sin square 2 pi ft, and option D is none of the above. So this question you can think of doing the actual Fourier transform of this function, and that will be very tough, because you see that this function will be a very complex function. So basically try to solve this equation, try to find the particular x of f by doing some tricks of the duality property of the Fourier transform, or it will also take some convolution property type of thing. So basically you have two square pulse, and if you do the convolution between two square pulse, it will be a triangular wave shape function. That is a task you can do in the home as an assignment of this particular problem solution. So basically you take two different square waves and just do a convolution, it will always come a triangular waveform. So basically if we do the convolution of the two different square pulse, we will get a triangular waveform that will be defined by this. And we know what is the Fourier transform of a particular square pulse. The Fourier transforms are sinc. So basically if I multiply two different sinc functions, so basically what is the task here? Let me say it. So suppose we have a sinc function, and if we have a sinc function here, it will have from the duality property, it will have a square pulse representation, right? So actually doing the integration over a sinc pulse and doing the integration over a square pulse, what will be the easier case? If you want to calculate the energy type of thing or that sort of thing. So basically if you multiply two different sinc pulse, it is equivalent to do convolution between two square pulse in the another domain. So multiplying two sinc pulse in time domain is equivalent doing convolution in frequency domain. And vice versa. So again, I have mentioned that doing convolution of two different square pulses is comes in as a triangular wave function. It results, if we do the convolution between two square pulses, it will result as a triangular wave function. So basically, if I multiply two sinc functions, it will give me a triangular function in the another domain. So that is the reason most of the options are in terms of sinc square. So basically, we are multiplying two different sinc function and we are getting a triangular wave function. That is the fundamental thing why we are taking that sort of thing. Now let us actually derive what will be the parameter values, like whether it will be multiplied by 2t or only t or t square, that we have to count. So first, let us write a rectangular function 2t. So what does that mean? It is a rectangular function within a limit minus t to t. So we know it has a representation in the Fourier domain of like this. So basically, if I have a time domain function and we just integrate over minus infinite to infinite to exponential e to the power j 2 pi f t dt, that sort of thing. So basically, it will come this sort of function. I mean d omega, df. So this is the Fourier domain representation of the rectangular pulse. So xt, that is the signal, is rect of t by 2t. What is this xt? Xt was the signal, this triangular signal. Into, this will be multiplication. Sorry, that is convolution in this case. As I mentioned earlier, that if I do convolution between two rectangular self pulse, it will come a triangular pulse. So first, what we started, we just writing xt in terms of the sinc functions from the duality property. So basically, again, now see, this is the convolution. So basically, what it will convert? It will convert as a multiplication. So what will be the x of f? X of f will be 2t sinc square from this property. I am just converting this rect to this sinc. Just converting from this time domain to frequency domain and converting this convolution to multiplication. As I mentioned earlier, like if I do convolution in this domain, that will give me a multiplication of two different sincs. This is multiplication, this is convolution here. So basically, the correct option will be option C. Okay. And again, if you want to calculate, just simple notation, if you want to calculate what is the actual energy of a sync pulse, I mean you are interested in calculating an energy of multiplication of a sync pulse and this sync pulse. There are two sync pulses, sync 1 and sync 2, and you will get a sync function like sync 1 sync 2 and some actual coefficients of that matrix, like it is a1 a2, so a is equal to a1 a2. In this time, if someone asks you to calculate how you can calculate the energy of the multiplication of these signals, so if you want to calculate the energy in this time, so you have to do the calculation minus infinite to infinite the same signal. I mean, if a1 sync 1 into a2 sync 2 mod square and over dt. So this process is a very hectic process. So in this time we can apply the Parseval's theorem. So what Parseval's theorem says, we have a time domain signal xt and it have a Fourier domain representation. So these two terms will be always equal. So basically we can convert this time domain signal into its Fourier representation. So if we have a sync pulse and sync pulse multiplication, we know it will be a convolution in the frequency domain. So basically it will come a triangular wave function. So from sync square it comes a triangular wave function, and performing this integration over this triangular wave shape function is much more easier than doing this particular integration over this time domain signal of sync, because this sync stretches to minus infinite to plus infinite, but this triangular wave function is just like it is band limited sort of thing. It is not from minus infinite to plus infinite. So performing an integration over a particular band limited region is much more easier than doing the particular integration in the time domain region. So we must always be focused how to get the utility of duality property of Fourier transformation. Okay, let us move to the next question. The next question says, suppose we have a signal xt and this signal is defined by it is 2b if t less than 0 and it is minus 2b if t is greater than 0. So what will be the representation of xt given 4 options? I will write the options. The first option is 2b limit b tends to 0 e to the power bt u of minus t u of minus t minus e of minus bt into u of t. The second option is b limit b tends to 0 e to the power bt u of minus t minus e to the power minus bt u of t. Next option is 2b limit b tends to 0, e to the power bt u of minus t plus e to the power minus bt to u of t. So what will be the correct answer? Okay. So the function was written as xt is equal to 2b if t equal to 0, t less than 0 is equal to minus 2b if t greater than 0. This was the question. So let me draw this thing. So for t less than 0, it is 2b level, and for t greater than 0, it is minus 2b, and here is a discontinuity sort of thing. So this function is somehow equivalent to writing u of minus t. So u of minus t is positive in this direction. This part is 2b u of minus t, and this part is 2b minus 2b u of t. So we can write, combining these two equations, is u of t and limit b tends to 0 e to the power minus bt. So as b tends to 0, this function will have a value 1. At this particular value. So the other options, if we see, it is 2b, but the actual value is 2b, but it shows that it's only contains the value b, so it does not reproduce this signal actually. Similarly, if we think this signal about this signal, this is just adding a summation. If we do the summation here, it will be this signal for option C. If we take option C, so sufficiently C also does not reconstruct the particular signal. So the correct answer will be answer A. Now the same question with this signal xt. The question is different. Xt is same. Just remind this function and we have to calculate what is the Fourier transform of 2 of u of t, 2 into convolution of u of t. Sorry. Just let me get clear once again. This is not the question. Sorry. First, we need to calculate what is the Fourier transform of x of t. So how we represented x of t? According to the previous question, x of t is equal to this one, 2b u of minus t minus 2b u of t multiplied by e to the power minus bt. So let us write it once again. This is equivalent to 2b limit b tends to 0 e to the power bt u of minus t minus e to the power minus bt u of t. Right? This is what is the function x of t. Now we want to calculate what is the Fourier transform. So what will be the Fourier transform of the function e to the power minus bt ut and e to the power bt u of minus t. So basically it will have a Fourier transformation of 1 by b plus j omega. And it will have 1 by b minus j omega. Why so? Like just do for one of them, e to the power minus bt ut, and we want to do the Fourier transformation here. So if we do that, it will come from minus infinite to infinite. It will only be limited to 0 to infinite, as ut function will disappear, and it will be minus b plus j omega into dt to t, that sort of thing. And if we do this integration, this 1 by b plus j omega term will come below. You can do this derivation in your home. So basically this 1 by b plus j omega is here. Similarly, if we do this function, it will give us 1 by b minus j omega. So if we do the Fourier transform of the function xt, that is just the linear combination of these two functions, and we know what is the actual Fourier transformation of these things, and also Fourier transformation follows the linearity property. So that what does means that if I have x1 of t plus ax1 of t plus bx2 of t, that we have a similar Fourier transform representation x1 of f and plus b of x2 of f, where x1 have a representation of x1 and x2 has a representation of big x2. Following this, if we substitute these two formulas, 1 by b plus j omega and 1 minus b of j omega, we'll find that the function xt will have a Fourier series representation, Fourier transform representation, like b tends to 0, 2b. For this, b minus j omega term will come, and for this, 2b by b plus j omega. This two term will come. It gives b plus j omega and gives 1 minus b by j. If we substitute these two terms and just calculate it, it will be 4jb by omega. So basically, it is the Fourier transformation of this sort of signal. Here is a little bit discontinuity because this signal just changed rapidly here. This is the time domain signal and this is the frequency domain signal. Okay. The last question for today. Okay, tell me.
Sir, this signum function, sir, can we directly multiply it with the function, considering this is as minus sigmund function? Can we do like that?
For this Fourier transformation? I mean, signum function, right?
Fourier transform of signum function, can we do?
You can use the duality property also here. From signum function, you need to know now what is the Fourier transform of signum function. This is the signum function for you, right?
Yes, sir.
So you have to know what is the Fourier transform of this signal. That is the only thing.
Okay, sir. Okay.
So basically, it comes from these two equations. I mean, how you can calculate the Fourier transform of a signum function?
I did by differentiation property, sir. This is
tell me what property you want to use here?
Differentiation property of when we differentiate, one impulse will be there at the origin, magnitude of minus 2a, and we will integrate that, and we will use 1 by 2 pi f 2 pi integration property of impulse at the origin.
That you can do, but yeah, that answer comes the same for you. I have not calculated in that way.
Okay, sir. Okay.
Just check it once again, huh?
What?
But there is a problem. How you can do the differentiation in this point, because this point is discontinuous according to this question. There is no value of t equal to 0.
We can use impulse of magnitude.
But there is no value at t equal to 0, right? Of this function. It was the question. Can you do the differentiation over xt at t equal to 0?
When discontinuity occurs, x of t 0 plus x of 0 minus divided by 2.
Yeah. You can think like that.
Okay.
And that is fine. You can think like that. But just check whether the answer comes same.
Okay, sir.
I will. Okay. The last question is, amplitude response of a purely imaginary signal is odd, whether it is true or false. Option A is true, option B is false. So again, if his signal is real, then in another domain it will be even. And a signal is purely imaginary. That means it is not complex. If a signal is complex, that means xr of t plus j of xi of t. If I mean a purely imaginary signal, that is jxi of t. There is no real component. If I mean a signal is real signal, that is x of r of t. If I say signal is complex, then this is the signal. So if a signal is purely imaginary, in that case, it is odd in the another domain. This is the duality property. So basically the answer will be true. Okay, so it was all for today's session. Does anybody has any query about all the problems I have solved? Okay, then it is fine. We'll meet in the next Sunday.
Sir, second question went out, sir.
Second question. Okay, second question was Noyan Suresh or someone has asked that what you solved are not with two assignment questions. So basically what I am solving is the previous year's week 2 questions, not this year's week 2 questions, because if I solve this year's week 2 questions, then there is no meaning of submitting your own assignments for grading. Okay. Question number 2 was like, we have a real signal xt, that question, right?
Yes, sir. In last step only, I am not able to understand. Last step, you substitute omega equal to 0, and how your answer is 0, sir. That step I can't understand.
Okay, the question was asked that you have a signal xt and you have to find what is the value of at x frequency domain. I mean, xt is a signal like
Yes,
this,
sir.
and the frequency domain will also have that type of signal. T and f. The question is, we have xt, and what is the value if we do the derivation of this signal 2 times x double dash t. Similarly, it will be reflected in the frequency domain also. So some different signal will come here. I say that is x2f, this is xf, this is xt, and this is x double dash t. So x double dash t probably, if I do the derivation of this signal, it will be like this t, and this is f. So my question was, what is the value of the signal at omega equal to 0? So if you derivate any function xt, xt will have xf. So the Fourier transformation property that we know, if we do one time derivation, what will be? It will be multiplied by j omega, x of omega, right?
Yes, sir.
Similarly, if I do by x double t, that will be j omega square, x of omega sort of thing. So omega you can replace by omega is equal to 2 pi f. So if f equal to 0, f is the frequency in hertz, omega is in angular momentum, right? Is it,
Yes, sir.
is it okay with you? So
Yes, sir. Yes, sir.
so the question was, what is the value of, I have a signal x double t, I have a Fourier representation of that signal x2 of f. What is the value of x2 of f at f equal to 0? At f equal to
Okay,
0.
sir. Omega value 0. Omega was there.
So that is the only condition, that omega is equal to 2 pi f. So if omega equal to 0, it is necessarily f equal to 0, right?
Yes, sir. Yes, sir.
So that means omega value is 0 here. X of 0 is, if it is x of 0, right?
Yes, sir.
So basically this omega value is 0. So whatever is multiplied by 0, that will be 0. So this value is 0, right? At x
Sir,
of 0.
actually we are finding the area now, sir. Area of time domain.
No, we are not finding the area of time domain. I just asked what is the Fourier series representation x double dash of t at omega equal to 0.
Okay,
Double
sir.
dash of t, that is a signal. It has a Fourier transform representation. And what is the value at omega equal to 0 of that signal?
Then what will be area of x double dash of t, sir?
What will be the area of x double dash t?
Yes, sir.
Here, this signal, we have not mentioned any property about the signal in the assignment. The question was like, the DC value of a real signal xt is defined as x of 0, where x of f is the Fourier transform. So we have not mentioned what signal is xt. So we cannot comment from this, only this information, what is the area under x of t, right?
Okay, sir.
We have
Okay,
not
sir.
represented any representation of this signal. We have just said we have a signal xt. We just do the double derivation of that signal x double dash t, and x double dash t will have a Fourier representation. So what will be the value of x double dash t? I mean, x double dash t will have a Fourier representation, and that will have some value at omega equal to 0 for x double dash t, the consequent Fourier representation.
Yes, sir.
So
So that omega equal to 0 means that value will be 0. Okay,
so
sir.
for x double dash t, there will be no DC value for its Fourier series representation. For x double dash t, not x of t. X of t may have a DC value at omega equal to 0. But if we think x double dash t, it will not have any DC component at omega equal to 0, right?
Okay, sir. Thank you.
Yeah. Okay. So I think nobody has any more query. So we can stop here.